Uh, Dear student, actually today we will see the next topic in the solution unit, that is vapor pressure. Okay, vapor pressure. For that topic we will see now. Actually, the vapor pressure at a constant temperature, the pressure exerted by the vapors of a liquid on its surface when they are in equilibrium is known as vapor pressure. In generally, taken a beaker is containing a liquid. For that liquid at room temperature, room temperature or the normal temperature, okay, normal temperature, this system is a closed in generally. So normal temperature and normal pressure, the liquid it has a some amount of thermal energy. Actually the liquid it has a some amount of thermal energy. For that energy, it's with the help of for that energy at the surface of the molecule. For the surface of the molecule, they have evaporated into this space. Okay, so now here the number of the gaseous molecules or gaseous moles, there is a number of gaseous moles that is representing the n, that is number of the gaseous moles that is representing the n. In generally the solid it has a thermal energy is less compared to that liquid, and gases as a thermal energy is highest. Gas as a thermal energy is highest. That is for the nothing but thermal energy order. Okay, so in general gas has a thermal energy greater compared to the liquid and solid. For example, that if you see the ice, in this ice we apply the thermal energy, it will convert to the water, and then again we can given in the thermal energy, it will convert to the gas. So for that reason the gas is a more randomness, as well as they have the highest thermal energy, and compared to the ice and water, the water also has a thermal energy. Okay, so for that kind of energy, the absorb the surface of this liquid, that will convert to the gaseous state. In the ideal gas formula, see the ideal gas formula. Now there is PV is equal to nRT. Here is a n as a number of moles, as a n. So if you assume as a mole is equal to 1, n is equal to 1, there is a PV is equal to RT. Okay, so now the in this formula there is a pressure as a directly proportional of number of moles, that n as a gaseous number of moles. Because of this formula as a ideal gas formula, for that reason the n as a number of the gaseous molecules. Okay, so in the case of the pressure as a directly proportional of number of the gaseous molecules of or moles, as a directly proportional. So that's why here the number of the gaseous molecules increases, actual vapor pressure increases. Okay, so in the case of the system, it containing the closed type, it containing the liquid, the surface of the liquid it will convert to the gaseous. So the gaseous number of solute or number of the solvent molecules increases, or number of the molecules are increases here. They have pressure also increases. So for that pressure, that is nothing but for vapor pressure. Okay, so the vapor pressure as a surface phenomena in this solution or in this liquid surface of the molecules are converted into the gaseous. Okay, so that vapor pressure as a surface phenomenon. Okay, okay, then next if you assume the boiling point that is for the bulk phenomena, because of the boiling point as for example liquid as a water, The boiling point of water is 100 degrees Celsius. Whenever for that temperature is reached, then only water is boiled. Okay, so the next factors affecting the vapor pressure. Okay, so next there is a factors affecting the vapor pressure. Affecting vapor pressure. What are the factors are affecting the vapor pressure? First of all, the nature of the liquid. Okay, so that is the nature of the liquid that is affecting, because the vapor pressure of liquid at a given temperature is independent of quantity of liquid and the surface area on the shape of the vessel. Okay, so for that yeah, the quantity of liquid as a independently the have creating the vapor pressure or affecting the vapor pressure. The next category, there is a temperature. Okay, the temperature, second category as a temperature. In generally, the temperature increases, actual vapor pressure also increases, because of, in this case of the liquid, it absorbs the thermal energy or temperature increases, the surface of the molecule are more easily evaporated into this vacuum. So for that reason, greater number of the gaseous molecules are presented in that empty space. For that why that's why the vapor pressure also increases. So the temperature is directly proportional of the vapor pressure. For that reason, yeah. Okay, the next actually there is a third type, the vapor pressure they have affecting by the external pressure they have affecting the vapor pressure, because in this case of this system it is a liquid. This surface of the gaseous molecules are evaporated into this space, for that have creating the vapor pressure. If you assume the external pressure or increases, okay, external pressure increases for evaporated gaseous molecules or decreases, for that reason the actual the vapor pressure or reduces. So that's why the external pressure are inversely proportional to the external pressure are inversely proportional of the vapor pressure. The next, there is a volatile, the fourth point, there is a volatile liquid as directly proportional of vapor pressure, and the non-volatile liquid as the inversely proportional of vapor pressure. Okay, because of the more volatile liquid they have creating the more vapor pressure, because they have more number of the gases molecules are occupied in the top of the that liquid. Okay, so the next, the vapor pressure of the liquid will decreases on increase of external pressure. For that one point is very important. Okay, so thank you to all. Actually, the vapor pressure, one of the very smallest topic in the solution unit, but it's a very easy topic. Okay, and also there is a very important, because they have relating in the theoretical question for NEET and JE, whether the directly relation between the vapor pressure and temperature, or the vapor pressure and external pressure is like that, they have asking the question. We will see for that kind of question after completion of entire this unit. Okay, thank you to all. If you like in this video, subscribe and share your friends. Thank you to all.